This video is brought to you by thepuzzler.com. The Phi-MC contest was a great success. It attracted over 200 participants from around the globe. In this video, we'll go over the questions and answers from the Phi-MC contest. We'll also have 2 giveaways including Amazon gift cards and a lot of Wolfram Alpha subscriptions. Starting with number 5. James has a number x and is supposed to multiply it by 2 twice, but instead he squares the number twice. Luckily, he got the same number as what he would have gotten had he done the arithmetic correctly. X can be written as a to the power of b divided by c, where a, b, and c are all positive integers, and b and c are relatively prime to each other. Find the minimum value of 100a plus 10b plus c. So now I'm just going to underline this word minimum because that means that there might be more than one value of this expression right here. If there's more than one value, then we have to check which one is less. Normally, the first thing I would do in a word problem like this is set variables. But they already give us the variable, it's x. So we can move on to the next step, creating equations. So they tell us that we multiply by 2 twice. Multiplying by 2 twice is 2 times 2, or the same as multiplying by 4. So we get 4x is equal to squaring the number twice. If you square x, you get x squared. And if you square x squared, you'll get x to the power of 4. Now we have a simple equation that we can try solving for. We know that x is not equal to 0. So we can divide by x on both sides to get 4 equals x cubed. Now we can take the third root of both sides to get 4 to the power of 1/3. Notice how I did that. So I took both sides to the power of 1/3, and whatever I'm doing to one side I have to do to the other side, so I took this to the power of 1/3. And the 3 and the 1/3 cancel out here. And we're left with 4 to the power of 1/3 equals x. So would our answer just be 413, since a equals 4, 1 equals b, and c equals 3? Well, remember that there might be more than one value. There might be. Not necessarily, but there might be. Notice that 4 is a perfect square. We can rewrite 4 as 2 squared to the power of 1/3 is equal to x. Now this 2, so anything, whenever we have something like this, a to the power of b to the power of c, this is the same as a to the power of b times c. So this is the same as 2 to the power of 2/3 equals x. Now a equals 2, b equals 2, c equals 3. I don't see any way to simplify this further, so our answer would be 223. Let's move on to the next problem. Problem number 8. Let a sub 0 equal 0, and a sub 1 equal 1, and a sub 2 equal 1. If a sub n plus 2 is equal to a sub n plus 1 minus a sub n plus a sub n minus 1, what is the sum of a sub 0 squared plus a sub 1 squared all the way to a sub 2021 squared? I doubt we're going to be calculating all 2021 or all 2022 terms, since there's the a sub 0 term. We won't be calculating all the terms, since that would take way too long for this test. The terms sort of do look similar though, 0, 1, 1. So we can try figuring out the first few terms, see if there's some sort of pattern or something. And let's do that. So we have that a sub 0 equals 0. Then the next term is 1, and then 1. Now we can calculate a sub 3. So a sub 3, so that means n is equal to 1, is equal to a sub 2 minus a sub 1 plus a sub 0. So we have that a3 is equal to, a2 we know is equal to 1 minus 1 plus 0. Or that a sub 3 is equal to 0. Next term, a to the power of 4. I mean, we're just seeing zeros and ones, so hopefully it'll just remain with zeros and ones and we might see some pattern. So we have a4 is equal to, let's see, that's equal to a sub 3 minus a sub 2 plus a sub 1. Because n in this case would be equal to 2. We know that a sub 3 is equal to 0 minus a sub 2, which is 1, plus a sub 1, which is 1. Another 0. Maybe all the terms are just 0 except for the original 2 1s that we have? Maybe. We have to keep on going though. So we have that a sub 4 is equal to 0. A sub 5 is equal to, I won't write it out all the way, but we know that it's just a sub 4, which is 0, minus the term before that, which is 0, plus the term before that, which is 1. Okay, now our next term, a sub 6 is equal to 1 minus 0 plus 0, or 1. Wait, we already calculated 1, 1 before, right here. This pattern 0, 1, 1, we only need the last 3 terms to calculate this next term, and we already calculated the pattern 0, 1, 1. So if it repeats, then the next term is just 0, and we already calculated 1, 1, 0 already, so the next term is just 0 again. And now we notice the pattern. Every 4 steps it repeats with the cycle of 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, and so on. So now what can we do? So we have what, 2022 terms, right? Because 2021 is 1 to 2021 is 2021 plus a sub 0 gives us one more term to give us 2022 terms. So 2020 is divisible by 4. If we divide 2020 by 4, we would get, what would we get? 20 divided by 4 would give us 505. And in each of these 505 cycles, there's 2 1s. So we multiply by 2 to get 1010. Now we have these last 2 terms left over, and they'll look something like this, 0, 1, because the sequence restarts. So we have 1, 1 there. So we would add 1 to this to get 1, 0, 1, 1. And that tells us a very important lesson. Whenever you see a recursive sequence like this one, try listing out the first few terms. It's possible that it might just be cyclic and it just repeats itself, making your job super easy for that problem. Now, on to the next problem. Problem number 9. There's a rectangle on a coordinate plane with vertices 0, 0, which is the origin, 0, 13, 5, 0, and 5, 13. How many rectangles can you make from using only these grid lines? So no diagonals, nothing weird, just a simple coordinate plane. So let me draw our basic coordinate plane, just a rough sketch. What do we see? Okay, we see that we have this point, 0, 0. We have 0, 13, which would be on the y-axis, right here, 0, 13. And then we have 5, 0, which would be somewhere here, 5, 0. And then we finally have the point 5, 13. Okay. And even if you confuse up your axes for this problem, it doesn't really matter since it's basically symmetric about the axes. But what do we notice here? We notice that we basically have a rectangle already, and I'm going to draw in a few of the grid lines. For example, for 5, 0, we would have 1, 2, 3, 4. Now for 13, we would have 1, 2, 3, 4, 5, all the way to 13. Okay, so what does that tell us? What do we need to make a rectangle? Well, a rectangle, let's draw a rectangle right here. A rectangle has 2 vertical lines and 2 horizontal lines that are parallel. Okay, so this might just be a combination problem, right? And by the way, if you don't know what combinations and permutations are, you can watch our video on that. You'll probably find a link to that in the description below. I heavily suggest watching that before you look at this solution. So out of these 6 lines that we have, so we have 1, 2, 3, 4, 5, and then don't forget the line at the origin. So that's 6 lines that we have. Out of the 6 lines, we have to choose 2 of the possible lines to represent where our lines are going to start for this part of the rectangle. For the vertical part of the rectangle, where is that going to start? Okay, so we have 6, choose 2. Now we've picked where it's going to start from the bottom, but what about from the sideways? We have 13 lines, 1 through 13, plus the 0th line, so that's 14. And we just have to pick 2 points. Maybe we'll pick this one and this one. Basically, out of the 14, there's 14 choose 2 ways of continuing. And I'm assuming you know this. If you don't, just watch that video. It'll keep you on track. So now we can figure this out. We have 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial times 2 factorial times, I'll just write this one as 14 factorial, 12 factorial, 2 factorial. So 4 factorial cancels out with 4 times 3 times 2 times 1. And then 12 factorial cancels out right here, leaving us 14 times 13. And we're just going quickly through this, but you can always just take an in-depth explanation at this. 2 factorial is just 2, so 2 cancels out with the 14, leaving us a 7 here. And the 2 factorial here cancels out with the 6, leaving us a 3. So we have 3 times 5 times 7 times 3. So what would be the best way to continue here? We should multiply everything other than the 5 first. So we have 7 times 3, 21. 21 times 3 times 5 gives us 63 times 5. Now what? Now how can we continue here? Oh, we actually don't have a 3 here. We have a 13. I accidentally copied that wrong. So we have a 13 right here. Okay, so we have 3 times 5 times 7 times 13. So now we can probably multiply the 5 times 7 first to get 35. 35 times 3 gives us 105. And now we have to do 105 times 13, which is the same thing as 105 times 10 plus 105 times 3. So 105 times 10 is 1050. 105 times 3 is 300. Let me erase that. 315. Adding this up, we get our answer of 1365. And that's how many rectangles we can make using only the grid lines in these points. Let's move on to the final problem before our first giveaway. Yes, our first giveaway. We're going to be having multiple giveaways in this video. Number 10. Circle A is centered at 1, 9 and circle B is centered at 5, 13. If they only meet at one point and neither circle is internally tangent to the other, then what is the maximum distance between a point on A and a point on B? Now, I'm not even going to draw a coordinate plane, but just the circles, just to get a rough sketch of our drawing. We have circle 1 and another circle. So now, if you think about it, and I'll leave this up to you, you'll realize that the two circles need to be congruent to maximize the distance. If this is the first point, this is the second point. Then, if these two circles are congruent, if we draw the line that connects them, you'll notice that the midpoint of this line is where the circles intersect, since that's a radius away from both of them. To find that point, you just use the midpoint formula, which is 1 plus 5 divided by 2, comma 9 plus 13 divided by 2. So the point where they both intersect equals 3, 11. Okay, and now we can use the distance formula to find the radius. Let's use 3, 11 and 1, 9 as our points. We have square root of 3 minus 1 squared. 3 minus 1 squared. We're sort of assuming you know the distance and midpoint formula for these two questions. Plus, we have 11 minus 9 squared. 11 minus 9 squared. This gives us 4 plus 11 minus 9, 2. 2 squared equals 4. Square root of 4 equals square root of 8. Square root of 8 equals 2 root 2. So the radius of both the circles is 2 root 2. Now, how would we maximize the distance between a point on A and a point on B? That would be exactly this point. The point that's a diameter away from the point that's in common to both the circles. It's the same for this circle. So the maximum distance could be 4 radiuses. 2 root 2 times 4. 2 root 2 times 4 gives us 8 root 2. So let's now move on to our first giveaway. It's giveaway time! Let's look at giveaway number 1. To enter the giveaway to win a free Wolfram Alpha Notebook Edition valued at $50, first, give this video a like. Second, comment down below in the video comments with your favorite question so far. And third, subscribe to our channel. Winners will need to make sure that they're subscribed to our channel to claim their prize. We'll be giving away 3 Wolfram Alpha Notebook Editions in this giveaway. So go ahead, enter right now. We'll give you 30 seconds to do this right now and then come back to this video. Problem number 12. Virat Kohli and the BCCI selectors have a list of 6 players to choose from for special training sessions. They really like Ashwin and Rishabh, who are also on the list of 6. The selectors want to pick 4 people out of the 6, including Ashwin and Rishabh. When announcing the players, to not look biased, they want to announce the 2 players, Ashwin and Rishabh, non-consecutively, which means not together. How many ways can the announcer say the names of the selected people in the training session? Okay, so first, out of the 4 other players of the 6, we have to pick 2 of them, so other than Ashwin and Rishabh, that are going to be on the team. Since there's 6 players, 2 of them are already on the team. Out of the other 4, we have to pick 2. So that would be 4 choose 2, which is 4 times 3 divided by 2 equals to 6. So there's 6 ways to pick the actual people on the team. Now the number of ways to announce the names. Okay. So we could have one of these 2 players. I'm just going to call him A and R for now. We're going to have them A and R, and then the other 2 players can be Y and Z. So we have A, R, right? We could have A and then R being announced last. Or we could have A being announced second and R being announced last. Now we can't have A right here because then if R is here, they're right next to each other. So these are all the possible cases. These are all the possible cases where A is going first and R is going second though. So now we need to double this because R could go first. So that would give us 3 times 2. And now Y and Z, in each of these cases, Y has 2 spots to go to and then Z spot is fixed. So we multiply by 2 again. So we get 3 times 2 times 2. That's the number of ways to pick the people once you have the people on the team. So we multiply by 6, since there's 6 ways to pick the number of people on the team, to get 6 times 3 times 2, which is 6 times 2. This gives us 36 times 2, which equals 72. And that is problem number 12. We're just 2 points away from our second giveaway, this time an Amazon gift card. In triangle ABC, there's a point X that is on the line segment AB such that AX equals 5 times BX equals 10. AC equals 13, BC equals 11. If CX can be expressed as the square root of A, then find A. Okay, so let's label the points. I already drew the triangle here, but you can always do that on the real test on a piece of paper. So we have A, B, and C. And we're told there's a point X, right here, I'll call that X, such that AX equals 10, and 5BX equals 10, so that means BX equals 2. We're also told AC equals 13, and BC equals 11. Now we're asked to find the value of CX. Now a problem like this should really make your head go to the Stuart's theorem. The Stuart's theorem states, given a triangle ABC with sides of length AB and C, opposite vertices are A, B, and C respectively. If CV and AD, that just means a line from a vertex to an opposite side. If CV and AD is drawn so that BD equals M, DC equals N, and AD equals D, we have that b squared m plus c squared n equals amn plus d squared a. Sometimes people also write it as man plus dad equals bmb plus c and c, which lets you really memorize it. Okay, so now how can we apply this in this problem? Well, notice that we're literally given everything except for the length of cx. So if we plug it into the Stuart's formula, we should get the length of cx, which is d in this case. So we have b squared m, so let's see, what is b squared m? That means one of the sides squared times the other expression, so this squared times side A, and the opposite part of side A, not n, the opposite part. So we get 13 squared times 2, plus we do the same thing for the opposite side to get 11 squared times 10 is equal to amn, a times m times n, which is a is 10 plus 2, or 12, times m is 10, or you can call it 2, it doesn't matter, due to the commutative property. So we have 12 times 10 times 2, plus d squared a. Now we don't know what d squared is, so I'll just call it d squared. Remember, d equals cx. We'll write that here, d equals cx. D squared a is just 12, so we have this expression. So now let's actually do some of this multiplication. It's a bit bashy, but we'll do it. 13 squared is equal to 169. 169 times 2 equals 170 times 2 minus 2, right? Make sure you get why that's true, because we added 2 and then we subtract 2. That's just 340 minus 2, which gives us 338. 121, which is 11 squared, times 10, that's just add a 0 to the end, you get 1210, equals 12 times 10 times 2. Actually, let's factor out the 12 here to get 20 plus d squared, because the 12 is common, so we'll probably need to divide by that anyways. So now on the left hand side, we have 338 plus 1210. Let's just add that up instead of doing anything more smart. Sometimes you just want to get the math done, get the arithmetic done out of the way. So we get 1548. Now we divide both sides by 12. That would give us 1. We would have 34 left, so that would give us 2, and then that would give us 10, 108. 108 divided by 12 would be 60 plus 48, so 5 plus 4, which would give us 9. 129 equals 20 plus d squared. Subtracting 20 from both sides, we get 109 equals d squared. Or that, taking the square root of both sides, square root of 109, square root of 109 equals d. So would our answer be square root of 109? No. We have to make sure that we reread the problem before we do anything else. It's asking us for this expression inside the square root, which is a. So our answer is just 109. Let's move on to the next problem. This problem was rather easy, and it's the last problem before our Amazon gift card giveaway. A number is called fantastic if it can be written in the form 13 to the power of x plus 5 to the power of x, where x is a non-negative integer. What is the number of fantastic numbers less than 2021? So first we need to find an upper bound. Notice that if x is 3, we would have 13 to the power of 3 plus 5 to the power of 3. 13 to the power of 3 is 169 to the power to 169 times 13, since 169 equals 13 squared. That's 1690 plus something approximately along the lines of, we can round 169 down to 150 to get 450 multiplied by 3. That is a lot more than 2021. So we can't even have x equals 3. Now we could have x equals 0, x equals 1. And since x squared, x equals 2 gives us such a small answer because this is just a bit over 2021. X 13 squared plus 5 squared would give us something along the lines of 169 plus 25, which is obviously much smaller than 2021. So x can equal 0, 1, or 2. That just gives us our answer of 3. Now we can move on to the giveaway. It's giveaway time, and this time we're giving away an Amazon gift card. To enter the giveaway to win an Amazon gift card, you have to do 3 things. First, make sure that you're still subscribed to our channel, and if you haven't done so yet, make sure you do it. Second, fill out the Google form in the description below. Third, comment below with your favorite part of the contest. 2 lucky winners will win an Amazon gift card. So go ahead and enter this giveaway right now. We'll give you some time. Problem number 19. Jeremy is going trick-or-treating. At every house, he spins a fair tetrahedral, or a 4-sided die, with the numbers 1, 2, 3, or 4, to decide how many candies he will eat at that house. The number that he spins is the number of candies he eats. Unfortunately, after going around approximately 4 houses, or exactly 4 houses, he gets a stomachache. What is the probability he ate 5 candies or less? Now this might look like a messy casework problem, but look at how small that number is. It's not like he can eat 0 candies at any house. He's gonna eat at least 1. So we can look at the possible cases. Well, he could eat 1 candy at each house. That would be 1, 1, 1, 1. That would give us 4 already. Maybe he could eat 2 candies at one house and 3 at the other houses. That would give us 5 candies. What else? Can he do 1, 1, 1, 3? No, that's too much. That's 6. What about 1, 1, 2, 2? No. And there's nothing else that could equal 5 or less candies. So these are the only cases we have to look at. So how many of this are there? Well, if he eats 1 candy at each of the houses, that's just one way that can happen. Here, out of the 4 houses, he has to pick which house he's gonna eat 2 candies at, and the other 3 houses he'll only eat 1 candy at. So that's 4 choose 1, which equals 4. So there's 5 total ways. Now, it's a probability question. So at each house, he has a 1/4 chance of picking whatever he has to pick. If he has to pick 1, 2, whatever he has to pick. And there's 4 houses, so 1 to the power of 4, 4. That's the probability of any possibility happening. And only 5 of those possibilities work, so we multiply by 5 to get 5 over 4 to the power of 4. That's 16 squared, or 256. Problem number 19 is now solved. Let's go on to the next problem. Problem number 22. Find the number of ordered pairs n, m that are there such that n to the power of 6 plus 3 equals m squared if n and m are integers. Okay, so for this problem, we can do a bit of arranging, or rearranging. So we have this equation. Let's subtract m squared from both sides. We would get that n to the power of 6 minus m squared equals negative 3. So I also subtracted 3 from both sides. Let me rewrite this, multiply both sides by negative 1 so that 3 is positive. So then we have m squared minus n to the power of 6 equals 3. Wait, this is just a difference of squares. We have m minus n cubed plus, or times m plus n cubed. And this is a Diophantine equation. So we can set, since both of these are integers, this is closed under integers, we can set each of these to a factor of 3. And we can solve to get valid values of m and n. That'll tell us how many values there are. So now, if m minus n cubed is equal to 1, so let me zoom out a bit. Okay, so I zoomed out a bit. So we have that if m minus n cubed is equal to 1, m minus n cubed equals 1. And m plus n cubed would then equal 3, right? Because 1 times 3 equals 3. You have n plus n cubed equals 3. Now we could add these two equations to get 2m equals 4, or that m equals 2. If m equals 2, we have 2 minus n cubed equals 1, 2 minus n cubed equals 1, or that 1 equals n cubed, and n equals 1. So our first solution is 2, 1. Now what if m minus n cubed is equal to negative 1? Then m plus n cubed is equal to negative 3, right? Because negative 1 times negative 3 gives us 3. Now we could add these two up to get 2m equals negative 4. M is then equal to dividing both sides by 2 to get negative 2. Plugging that in, we get negative 2 minus n cubed equals negative 1. Adding 2 to both sides, we get minus n cubed equals 1. Or that n cubed equals negative 1, meaning n equals negative 1. So our second solution is negative 2 comma negative 1. Now what? Now let's say m minus n cubed. So m minus n cubed is equal to 3. Then m plus n cubed is equal to 1. Adding up the two equations, we get 2m equals 4, or that m equals 2. It's just 2 for the x term and 1 for the y term. But the signs keep on getting flipped. So we have m equals 2, and we suspect y is probably 1 or negative 1. By y, I mean n. So we have 2 plus n cubed equals 1. So n cubed equals negative 1, and we're right. N is just equal to negative 1. So our solution, we have another solution, 2 comma negative 1. So our final solution, I suspect, is, if we look at the last case, is probably going to be negative 2 comma positive 1. But it doesn't hurt to check. If you have time, you should always check. So m minus n cubed equals 3. M plus n cubed, no, not 3, is equal to negative 3. And m plus n cubed equals negative 1, since negative 3 times negative 1 equals 3. We have 2m equals negative 4, and just like we thought, m equals negative 2. Plugging it in, we would get y is equal to 1. So we got 4 answers. Okay, but now that we think about it, we know that there could have been a maximum of 4 answers once we got our Diophantine equation, because 3 only has 4 factors. And look at that. All the powers in the original equation, n to the power of 6 plus 3 is equal to m squared, are even. So if, say, n is some even integer, it could also be, if n is some positive integer, it could also be the negative counterpart of that integer, and when you square it, you would still get the same answer. So when you take it to the 6th power, you'd still get the same answer. So same thing with m squared. For example, when we had 1 in our answer choice for m, well, we could have also always had, or when we had 2, we could have always had negative 2, and it wouldn't actually change the value of m squared. So our original square, 2 comma 1, actually had 4 possible answer choices, where you could flip the sign since it doesn't actually change the expression. So that's how we would easily find that the answer is equal to 4. Let's move on to the next problem. Problem number 23. We're almost to the results, guys. Triangle ABC has side lengths AB equals 21, BC equals 20, and AC equals 13. Point D is on side BC and point E is on side AC. These 2 points split their respective sides into the lengths shown in the diagram below. The area of the shaded quad DEAB can be expressed as m over n. Find 10m plus n. Okay, for this problem, we can find out a lot of the lengths first. So they tell us AB equals 21. Now DC is equal to BC, so DC is equal to BC minus DB, right? If we subtract that short segment from the long segment, we would get the length of DC. So we know BC is equal to what? BC equals 20, and DB, the diagram tells us, is 7, so DC equals 13. Similarly, CA equals 13, or AC equals 13, and CE equals 5, so EA equals 8. Now we can find the area of triangle ABC, right? There doesn't seem to be a nice way to find the area of DEAB, so we'll go ahead and find the area of triangle ABC, and maybe we could find the area of triangle CDE after that and subtract that from ABC to find the area. So almost like complementary area measuring. Okay, So we have Heron's formula. So we have our three sides, 21, 20, and 13. So we can use Heron's formula. The semi-perimeter is 21 plus 20 plus 13 divided by 2. Oops. We don't want that happening. Divided by 2. And S equals that. So we have 21 plus 20 equals 41 plus 13 equals 54. 54 divided by 2 equals 27. So the area of this triangle is square root of 27 times the square root of 27 minus 20, which gives us 7, times this 27 minus 21, which is 6, times 27 minus 13, which gives us 14. So this would be, let me just rewrite this as square. So 27 times 3 gives us 81. We took the 3 out of the 6. Times 2 times 7 times 14. 2 times 7 just equals 14. So if we have 14, if we take the square root of this, it would be 9 times 14, which is 140 minus 14, or 126. So the area of this whole thing, let me write it right here, triangle ABC, that represents area, those two square brackets. This total area is 126. Now we probably use something along the lines of similar triangles. Notice that triangle CDE and triangle CBA share the same base, right? In a way, they share the same base in ratios and the same height in the ratios. The area of CDE would be the same as CBA. Would they have had the same height and the same base? Now let's assume that they did have the same height. If they had the same height, then their area would just be the ratio of their bases, right? The ratio of their bases. So that would be CE over AE. Not AE, over CA. So that would be CE over CA. So make sure you understand why that makes sense. So if their height was the same, then the area of their ratio, since the heights are the same, it would just be the area of their bases, the ratio of their bases. So that would be CE times EA. Or CE over CA. That would be 5 over 13. So that equals 5 over 13. Now, what if instead of their heights being the same, what if their bases were the same length? Then the area ratio of those two triangles would just be the ratio of their heights. Well, the ratio of their heights is just 13. So DC over BC. It would be DC over BC, which is 13 over 20. So make sure you see why that makes sense. So even though 13 is not necessarily the height, the ratio would still be along that line. So we have 5 times 13 times 13 over 20 times the area of triangle ABC. Well, the area of triangle ABC we already figured is 126. Now doing a bit of simplification, 5 cancels out, leaves us 4 here. We get 63 over 2 as the area of triangle CDE. So our answer would be 63 over 2, and we would be not done. That would be a big mistake. Now we have to subtract this from 126. Let's write 126 with a denominator of 2, so that would be 252 over 2 minus 63 over 2. That would give us 252 minus 63. Now what do we do? Now we just do that subtraction. Doing the subtraction, we would get 12 minus 3, 9, 15 minus 7 equals 8. We get 189 over 2. Once again, you might put that as your answer and you would be wrong. Always look back at the question. So now this is a simplified fraction. We multiply the numerator by 10 to get 1890, and then we add 2. So our final answer is 1892. And that is problem number 23. One last problem before we look at the results of the Phi-MC contest. Number 25. There are 20 dots on a plane with no 3 collinear, which means that no 3 of them are on the same line. One of the points is labeled E, and the remaining 19 points have a different number, so I'll underline that, that seems important. A different number of line segments it connects to. Expected value of line segments connected to E can be expressed as m over n. Find 10m plus n. In this problem, what do we see? So we have 1 point E, and then we have 2019 more points. So we have a lot of points, 2019 more points. So out of these remaining points, the maximum a point can be connected to, so let's take this point for example, the maximum it could be connected to is, well, it could be connected to all the other points. There's 20 total points, but it can't be connected to itself, right? So that would give us the maximum number of points a line could be connected to is 2019. Now in this specific case where the maximum is 2019, if this line is connected to 2019, and so that means it's connected to every point, which means that every single point has at least one line connected to it. So we have 1 to 2019. Now we need 2019 different values, and from 1 to 2019, there are exactly 2019 different values. So that means that all the values in between are reached once. Now what? What if a point didn't hit any of the other points? What if this point, let's say, was secluded? It had some magic boundary that didn't let it reach the other points. Now the other points, the maximum could be 2018. So the minimum is 0. The maximum could be 2018. Can't be 2019. A point can't be connected to all the other points now because there's one point it's not connected to. And that would give us exactly 2019 distinct values. And both of these cases happen with a probability of 1/2. So now what? So now from 1 to 2019, the expected value, what's the expected value of the number of points that will hit line E? Line E could have any number of lines connecting to it, right? It could have anywhere from all 2019 of the points hitting it to only one of the points hitting it. It has at least one point hitting it. So what's the expected value? We find the average of 1 and 2019. That's 1 plus 2019 over 2, which gives us 2020 divided by 2, or 1010. Doing the same thing from 2018, we get 0 plus 2018 divided by 2 equals 1009. And that's basically almost it. Now we have to find the average of 1010 and 1009. So we do 1010, since the probability is equal, so we do that, add them up, and then divide by 2. What does this give us? It gives us 2019 divided by 2. And you would almost be done. But now we do this answer format. We multiply the numerator by 10 to get 2019, and then you would add a 0 at the end, but we add 2 also. So our final answer would be 2019-2, or 20,192. And that's how easy number 25 was. Now, let's look at the results. Time for the results. Here are the smart individuals that were able to snag a spot in the Phi-MC standings. The results are being announced through the chat right now. Thank you. The Phi-MC community thanks you for participating in this contest. Thank you for watching this video. If you liked this video or learned anything from it, let me know by subscribing or commenting below. For more awesome content, check out thepuzzler.com. You'll find amazing articles and free courses there. Thank you.